Good evening everyone. My name is Alihan and today my presentation topic that is super tough polylactic acid PLA polybutylene succinate PBS material prepared through reactive blending with epoxy functionalized PMMA GMA copolymer. This paper is published in the Journal of International Journal of Biological Macromolecule in the year of 2023, and the impact factor is 8.2 in 2023. Outline contain introduction, materials and method, result and discussion in conclusion. In the introduction part, the polymer like PLA, PBAT, PCl, PBS, PBSA and PHA and so on. There are so many polymer. These are biodegradable polymer which has positive impact on the environment. So that's why nowadays researchers more focus on this polymer. PLA and PBS, one of them. So PLA has some property like they are biocompatible, mechanical, they have good mechanical strength and easily processable, but due to poor thermal stability and brittleness, it affects their applications. So to improve these properties, so another we need to combine with another polymer. The author try to make blend with PBS. So PBS has good chemical resistance, this is also biodegradable and heat resistance, so it can enhance thermal stability and also the tensile strength. But the issue is this, if the PBS content increases in much high concentration, so it also have some limitation. So that's why the researcher they make blend. In this paper the author try to use compatibilizer which can improve the compatibility, the miscibility of PBS and PLA with each other. So by using compatibilizer PMMA and GMMA, so it will work as a bridge. It will connect both of them with each other, so it can improve their property. So the materials used in this research article, that is PLA, PBS, PMMA, GMA, and the detail are present below. After the next step is materials and method. So in the methods, material we discussed before this one, and the methods. So the author he used hockey batch mixer. So the author used hockey to make polymer blend. So it consists of two steps. In the first step, before the processing, he dry PLA, PBS and the compatibilizer at 60 degrees centigrade per 12 hours. After that, in the first step, PLA and PBS are combined with different ratio, and combine in the like they mix with each other and introduced to hockey. In the hockey, the temperature is 190 degrees centigrade, the RPM is 80 and per 4 minute. After melting the blend, they introduce the compatibilizer PMMA GMA compatibilizer and remelt again at 190 degrees centigrade at 80 RPM per 10 minutes, and the resulting polymer blend was received and then hot pressed into a sheet with a thickness of 1 and 4 millimeter. And the polymer blend which was formed have different weight percentage of PLA, PBS and the compatibilizer. All data are shown in the table. So they also make control per PLA, also per PBS and also per this one and also per blend. So in this portion we will know the he make PLA, then also added the compatibilizer 1%, 3% and so on. After that they make PBS and the compatibilizer was used with different weight percentage, and after that the blend was made, PLS, PLA, PBS, and weight percentage of the different weight percentage of the compatibilizer. So looking to the result and discussion section, the first figure show the PLA stress strain curve. Actually the PLA show brittle fracture surface, so the tensile property of the PLA is little bit improved, and also some to some extent up to 7.6 the elongation at break also increase. Looking to the PBS, so the PBS surface is ductile surface, so at the tensile strength little bit improve, but while the elongation at break highly improve, more than 446, more than that percentage. It's also improved by introduced the compatibilizer. After that, the main thing is this one. So they make blend PLA with PBS, and different weight percentage of compatibilizer was 8, 1, 3, 5, 7, and 10. So the data show here. The tensile strength of PLS is 42. It is improved to 46. The tensile modulus, or we can say modules, is 1194 plus minus 85. It also improved. Elongation at break, it is 11.2. It improved very high. After that, impact strength. So PLA has very low impact strength, PBS high, and the PLS is also low. So after making the blend, the PBS 5.8, but after adding the 1% compatibilizer, it increases almost double, and after that increase the content of compatibilizer, so the impact strength also increases, which show the brittle ductile transition. So looking to the ECM images of the blend, also the PLA, PBS, and the blend. So the PLA surface is show a very smooth and homogeneous surface with a small tiny pits indicated. So the surface is very smooth, so it show it is brittle surface. While by adding 1%, 3%, 5%, by adding the compatibilizer, the surface change little bit, so which show some fibers also and on the surface of PLA, which so the brittle surface vary, so which can show the improve of toughness the surface, because from the surface we can say that the toughness of the PLA is improved because of the compatibilizer. After that, PBS, so the PBS surface is very rough, which show the surface is very ductile. After adding compatibilizer, the surface is changed from very rough surface to very rough surface, it will be more ductile. So after adding the compatibilizer, the surface is a little bit changed. It like more continuous, like some platelets and sheets and ribbons are present, some fibers are present, which show the increase in the toughness. It's because of the epoxy functional group present, so that's why, because of the epoxy and hydroxy group between PBS and the compatibilizer, because compatibilizer contain epoxy group, so it reaction, because of the reaction there are so many fibers are made, so the surface change little bit change. After that, PLS. In PLS, it is the combination of PBS and PLA. Some PBS particle cavitation was observed here, which show the shear, which can easily show the shear yielding, and also by adding 1%, 3%, and so on the compatibilizer, so the surface become more rough. Here is like little bit not too much, but little bit look like similar to this one, not too much but little bit. So it is easily fracture as compared to this one. So this surface is rough surface which show the compatibility is increased, which can improve their toughness, and also it show a fine dispersion pace pace separated morphology. It's observed here. So from the SEM image we observe that PLA surface is very smooth, this is very rough. By combination the surface is changed, but by adding this one the surface is more changed, and which can easily show that the some property will be changed, so the surface become more rough and it will be more toughened. Furthermore, it is very important characterization or we can say application of the polymer blend. So now looking to the thermal behavior of the polymer blend. So the first figure it show the DSC heating and cooling curve. So the temperature, the heating is we give the author give heat and also cool at the rate of 10 degrees centigrade per minute. So PLA heating curve show the first one is the cool crystallization. So by adding the compatibilizer to PBS, the cool crystallization, so here the cool crystallization temperature, the cool crystallization it disappear, which show the formation of crystal. It can improve the crystallization. Like here is there is like the peak show TCC of 109.6, but while adding the compatibilizer it disappear, which mean that the compatibilizer help to improve the crystallization. So looking to the here, the TM of PLA is 169.4 degrees centigrade. By adding the compatibilizer at about 162.9 degrees centigrade, it decreases. So in the polymer blend, we can say that if the melting temperature of the polymer blend is decreases, it means that the polymer like each other, they have miscibility with each other. So we can say here the miscibility is increases. And another point is the second melting temperature. So the second melting temperature here, it's like a small, it's also disappear, which can also show the improved crystallization. Here in the cooling, because of the amorphous nature, they have no TC, while by adding the compatibilizer, a small TC is observed, like at 107.8, which is the evidence which show that it helped to improve nucleation of like mean crystallization. So from this data we can say that the crystallization is improved because of the PLA. So looking to the PBS, so PBS has T melting, TM is 114.4 degrees centigrade. By addition of compatibilizer, not a big change was observed, but while the second melting peak, if we observe here, it is not a big one, but by adding the compatibilizer, the second melting peak is observed, which clearly show the enhancement of crystallization and also the transition of alpha crystal formation. After that, in the TC of the PBS is 74.6 degrees centigrade. By adding the compatibilizer, it increases to 92.8 degrees centigrade. It increases mean that it help in the nucleation to improve crystallization. So it also help to improve the crystallization. Now come to the blend, which is the most important one. So in the blend system, they show two, this is for pair PBS and PLA. So this is the blend. So this peak, they show two peaks. This peak show it is because of PBS 114.4 degrees centigrade, and this one because of PLA. So looking to this one, here it is discussed. So the T melting point because of PBS is 114. So by adding a metabolizer, it is decreased slightly. So decreased slightly mean they show some little bit miscibility, and same like here in the PBS, the second melting peak also observe. It means that they improve the crystallization. Looking here, because of PLA it is 168 and it is decreases up to 162 is because of the miscibility. So because of the miscibility they and also nucleation and nucleation of crystallization, the TM of PLA portion is also decreases. And the TC cooling crystalline temperature, it also increases, which show that the the convertibilizer help in the nucleation effect, in which crystal formation is dominant, is form. Not dominant, I mean that the crystallization mean crystal form. So looking to the wax,